Hi, and welcome to the lesson on phylogeny. When you are done with this lesson, you should be able to compare the Linnaean and phylogenetic classification systems, and you should also be able to describe what a clade is. All right, so if you've not already kind of watched or read the introduction about taxonomy, please do so before continuing with this lesson, because I'm going to make the assumption that you've already taken a look at that. All right, so phylogeny is like an organism's family tree. And I'm going to need my kind of pen tool here. Understanding phylogeny is a lot like reading a family tree, where the root of the tree represents the ancestral lineage, and the tips of the branches represent those descendants of that ancestor. So, got our common ancestor back here, and then these are going to be those descendants. Okay. As you move from the roots to the tips, you are going from the past to the most recent. Speciation is represented as branching. So when a lineage splits, that is representing a speciation, represented as branching on a phylogenetic tree. So when a speciation event occurs, a single ancestral lineage gives rise to two or more daughter lineages. So we've got this common ancestor here, some kind of event, then that's causing that to split. Phylogenies show shared ancestry and uniqueness. Phylogenies trace patterns of shared ancestry between lineages. Each lineage has a part of its history that is unique to it alone, and parts that are shared with other lineages. So they've already kind of got these color-coded for us. So B has got its own unique history, C its own unique history, and then this history would be shared between B and C. And again, A would have its own history over here, but it would actually have a shared history with B and C if we go far enough back. Each lineage has unique and shared ancestry, so similarly, each lineage has ancestors that are unique to that lineage and ancestors that are shared with other lineages. Kind of what I had just mentioned here. Well, I was talking about its history, but here we're talking about those ancestors. So unique to C, common for B and C, and then common for A, B, and C. A clade is a grouping that includes a common ancestor and all of the descendants, living and extinct, of that ancestor. Using phylogeny, it is easy to tell if a group of lineages forms a clade. Imagine clipping a single branch off the phylogeny, and all the organisms on that pruned branch make up that clade. So here, these ones all have a common ancestor. That would be a clade. You could also kind of zoom in and just look at that clade. This is not a clade because they do not have a common ancestor without going farther back here and going into separate branches. So those are not considered to be clades. Likewise, this one over here is not a clade. This one itself would be a clade. You could also go like this. That would be a clade. this individually would be a clade. Or if you were to include the whole thing, these all go back to this point. That can be considered a clade because you've got that common ancestor. These ones over here do not have a direct common ancestor. And likewise, clear that up here. Over here, you're missing this one here, so not a clade. Clades are nested within one another. They form a nested hierarchy. A clade may include many thousands of species or just a few. Some examples of clades at different levels are marked on the phylogenies up here, these phylogenetic trees. And so here too, they're just showing more clades and showing how those clades can overlap, or as they say, nested. It's important to remember when reading a phylogeny to keep these things in mind. Evolution produces a pattern of relationships among lineages that is tree-like, not ladder-like. Evolutionary patterns are tree-like, not ladder-like. Okay, so it is not as simple A to B to C to D. C and D are shared, all right, and have a shared experience with B. So it's not a case of going from one to the other. It's not linear. Position has no advancement correlation. So just because we tend to read phylogenies from left to right, there's no correlation with a level of advancement. Okay, so we cannot say that D is more advanced than C, which is more advanced than B. They're just different species. This has been misinterpreted by some scientists in the past, and even by social scientists, sociologists and such, have misinterpreted this in the past, what's sometimes referred to as social Darwinism, which, again, if you're interested in that, you can find some cases in history where that's been misapplied. For any speciation event on a phylogeny, the choice of where lineage goes to the right and which goes to the left is completely arbitrary. It's just up to the scientist. So the following phylogenies are equivalent. So you can see that moss is mirrored here. And then this clade here is on the left, or it's on the right here and on the left here, but it's still showing the same relationships. All right, so summarizing, recall that the Linnaean classification is based on similar physical traits. That phylogeny is the evolutionary history of a group of related organisms and represented by a tree that shows how species are related to each other through common ancestors. A clade is a group of organisms that includes an ancestor and all of its descendants. In a phylogenetic classification, it is a phylogenetic classification then based on evolutionary relationships when you're talking about clades and phylogenetic trees. You can find a lot more, and almost all of these resources I've used in this lesson come from the evolution.berkeley.edu website, so you can check out some more there. It goes into much more detail. You can also check out the evolution labs over at Nova Labs. So there's some different practices and missions there. And at some point, I will actually have you guys completing those missions 1 through 6, where you get to practice making some evolutionary trees. All right, so now you should be able to compare the difference between Linnaean and the phylogenetic classification, kind of those two different systems and how we've kind of merged those two, and also be able to describe a clade with those common ancestors and descendants.